typical binomial questions. Use the binomial theorem to find the term independent of x in the expansion of 4 over x plus x squared to the 15. And this was this one where we were doing our summary, where I was trying to say if you had x to the power of a plus x to the power of b all to the power of n, we had to add the indices to work out the particular term that we wanted. So this is this kind of question where you've got something over x and then you've got an x squared. Now my suggestion is for 90% of these kinds of questions, it is a really good idea to write them in that sigma notation, to come up with that general term, and then you can see which term you actually want. So we start with r equals 0, we're going up to 15. Then we have 15CR, which is our coefficient. And in this case here, I'm going to call that 4x to the minus 1. Now, that's to the power of 15 minus r. And then we've got x squared to the power of r. Okay?
Wait, what's R?
Or K, or do you want K?
Yes, please.
Oh, but,
It's hurting to look.
oh.
It's
Okay,
hurting to
it
look.
looks like a V.
Okay.
What do you mean? Oh.
Just know that K or R could be in there, so please be okay with both.
Hot. Good one, miss.
Okay with both, yeah. All right, now, if we want the term independent of x,
0.
then you want the term that is x to the power of 0. So you wanted that when you multiply this x to the minus 1 to some power by this x squared to some power, when you add those indices together, you're going to get 0. So you want x to the minus 1 to the power of 15 minus k times x squared to the k to equal x to the 0. So what do you do with these indices? Well, when you times the base, you add the indices. So you want minus 15 plus k plus 2k to equal 0. And that gives me 3k equals 15 and k equals 5. Now, have I answered the question?
No.
I've only found the value of k that would give the term that's independent of x. They want the term that is independent of x. So we've got to say, therefore, term independent of x equals, and we go back up here. But what are we going to put in for k? We're going to put 5 in. So the term is going to be 15c5 times 4 to the power of 15 minus 5, which is power 10. Now I don't need to put the x in because we're going to end up having the term independent of x. It's not going to be there anyway. Times, is there any coefficient here?
No.
It's just 1, right? So that's not going to make any difference, but I'll pop it in just so that you see how I've substituted each of the coefficients in. And if you do that, that's 15c5 times 4 to the 10. And it's a nice small number. 3, 1, 4, 8, 8, 7, 3, 7, 2, 8.
So that's